The other type is where you combine addition and subtraction in an equation. Now you might think that this might be more difficult, but you'll see it's actually easier than adding and subtracting. Remember that when you added or subtracted, you needed to find a common denominator. Or if you like my child analogy or toddler analogy where they always want what the other one has, it makes this real easy. So first off, I have to find a common denominator. So you have a denominator here of this and a denominator here of this. So the fraction on the left here has a 7, but he sees over here, it's like, hey, wait a minute, that one's got an x. I want an x. So this one gets an x multiplied to it. The one over here is like, hey, wait a minute, that guy's got a 7. I want a 7. So you multiply this one by 7. And that's really all there is. Now the final one, 6, is 6 over 1, doesn't have either of them. The one over here is like, hey, that kid's got a 7 and that kid's got an x. I want a 7 and an x. So you have to multiply by both of them. Now, in this process, I'm not going to go into detail of why this happens, but by multiplying everything by a common denominator, your denominators actually are going to cancel out. So you just do the simple multiplication and solve. X times 4 is 4x minus 1 times 7 is 7 equals 6 times 7x, which is 42x. Now, I just solve. Subtract the 4x over. That's going to get a funny fraction here, but I get negative 7 equals 38x divided by 38. And I get x equals negative 7 over 38, which I know is a weird number, but that's what it is. So they can be that simple. So let's look at 6. Remember, each fraction wants what the other one has. So this fraction over here, the denominator is like, hey, wait a minute, this guy's got an x plus 2. I want an x plus 2. So you multiply this side by x plus 2. And then this one's like over here going like, hey, wait a minute, that guy's got an x plus 1. I want an x plus 1. So you multiply this by x plus 1. The answer, the last term over here is like, hey, that one's got an x plus 1. I want an x plus 1. So you multiply by x plus 1. Essentially, you're just multiplying by whatever denominator is missing. You have x plus 1s and x plus 2s. So whatever one that the denominator doesn't have, that's what you multiply by. Now again, I'm not going to go into this unless you want to know. You can come ask me. But why this happens, but when you multiply everything by a common denominator, your denominators will cancel out. So all you do is all the multiplication. So 3 times x is 3x. 3 times 2 is 6. Plus 4 times x is 4x. 4 times 1 is 4. Equals 15 times x is 15x. And 15 times 1 is 15. And you just solve. 3x and 4x make 7x. 6 and 4 make 10. Subtract the 7x. I'm going to move the 7x over here by subtracting it. And I get 8x. I'm going to move the 15 over here by subtracting it. That's negative 5. Divide by 8. Divide by 8. And you get x equals negative 5/8. So that's solving. We'll do one more type of problem. Okay. What about a problem like this? So here's where I'm going to need, remember, whenever possible, you should always try to factor if you can. So whether that's GCF or ABC or whatever, if you look at this term here on the end, I can take out an x here. I can factor it using GCF. So if I take out an x, I get an x plus 4. So now it's real easy to see the common denominators. So this fraction here is like, hey, wait a minute, this one has an x. I want an x. So it gets an x times x. And this fraction over here is like, hey, wait a minute, this one has an x plus 4. I want an x plus 4. So you multiply by x plus 4. Now, the term on the right already has an x and an x plus 4. It already has both toys. So it doesn't need any more. You don't need to multiply this one by anything. It already has both denominators. So in this process of multiplying by common denominators, your denominators will cancel out, including this down here. And we multiply. Let's change colors here. 12 times x is 12x. Now we have to be careful. This is actually a negative 7. So it's negative 7 times x is negative 7x. Negative 7 times 4 is negative 28 equals 22. 12 and negative 7x is 5x minus 28 equals 22. We're going to add the 28 over here. And you get 5x equals, I think, 50, right? And then divide by 5. X equals 10. So sometimes you'll get one answer. Sometimes you might get multiple answers. This can get, so number 9 is very similar to the one we just did. Number 10 would be a problem where you would have to factor this first to see what's missing. I think it factors to x minus, nope, not 5, x minus 4 and x minus 1. So you can see that this fraction would need the x minus 1, and then this one wouldn't need any, and then this one would need the x minus 4. And so you just multiply everything out and solve. That's it. That's solving rational equations.